purpose of this video is for you to be able to balance chemical equations. Now, if you look, this chemical equation on the reactant side, I've got two hydrogens on the product side, so they're currently balanced, but I've got two oxygens here and one over here, so it's not balanced. I'm going to show you two ways to do this. I can track how many I have. I've got 2 and 2 and 2 and 1. And I can only manipulate the coefficients in this process. I could just put a 2 there and then it would be balanced, but I'd be manipulating what it is. So don't change your subscripts. So I'm going to put a 2 there. Only change your coefficients, only them. So that gives me 4 hydrogen and 2 oxygens. Now my oxygens are balanced. However, my hydrogens are not. So then I come back over to here and I put a 2. And then it's balanced. Now another way to balance this is to draw it. Now, when I do this, I can only add it in the way that it's represented. I can only add it in the way that it's represented. So I have a lacking of hydrogen here, of oxygen here. I said that wrong. I have more oxygen on this side of the arrow, the reactant side, than I do the product side. So I need another whole water molecule, and then another whole hydrogen molecule on the other side to balance it. And then I write in my coefficients, 1, 2, 1, 1, 2. Now, is this one balanced? I've got Na and I, 2, 1, 1, 1. So it's not balanced. I just paused it and I drew it in. You can see it's not balanced. I've got more I's on the reactant side than I do here. So I need to add it like that, and then I need another Na over there. Now, essentially, I'm putting a 2 here and changing this and this to 2 and 2, and a 2 there, and now it's balanced. Now, another hint is for polyatomic ions, you're going to keep them together when you balance it out. Now, you can notice this one has got a polyatomic ion right here and there. It's on a hydroxide atomic ion. So when you go to balance it, track them together. Keep it together. I've got 2, 1, 1, 1, 2, 1, 1, 1. I'm going to pause this. Now you can see that I've got more hydroxide on the left side than I do on the right side. So I have to make that right. So I'm going to add a whole lithium hydroxide. And that's going to knock out, I have more lithium on this side now. I've got 1, 1, 2, and I only have 1, so I need a whole nother lithium chloride. So I'm essentially putting a 2 there, and I'm going to get 2 and a 2, and I'm essentially putting a 2 there, and that gives me a 2 and a 2. And now it's balanced. Here's another equation. Now this one is a little trickier because I've got a big hydrocarbon, that being butane. And it gives me 4 carbons, 10 hydrogens, and 2 oxygens. And over here, I've got 3, 2, and 1. The hint with this one is do your elements last. I've got oxygen here all by itself. So when I go to balance this equation, I should just forget about oxygen until the last thing. Do the other ones first so that it balances out. Now, I've got 4 carbons, 4 carbons here, and I've got 1, so I'm going to put a 4 there. That's going to change this to a 4 and give me 4 times 2 is 8, plus 1 is 9. And therefore I'm going to have 4 of these. So 1 times 4 is 4. Okay, now that balances out. Now I want to balance out the hydrogens. I've got 2 and 5, so I want a 5 here. That's going to give me 10. 5 times 1 is 5, plus 8 is 13. All right, so then I'd need 5 of these. Now the trick is, there's no way to get 2 to get into 13. I need it to be whole numbers. I need this to be a whole number. So what I could do here is multiply every one by 2, each one by 2, to turn this into an 8. That would give me 8 hydrocarbons, 8 carbons, 20. Oh, I made a mistake there. No, I didn't. Sorry, 20. I thought I made a mistake. 20 there. And then 10 plus 16, 26. And then I'm going to put a 13 there and a 2 there, and it'll balance. So I'll have 8, 2 times 10 is 20, and 13 times 2 is 26.